Alright, what is up everyone? Here we have problem number 15 of the MIT integration bee. We're integrating the integral from 0 to pi over 2 of the cosine x over 2 minus cosine squared of x dx. So the first thing I want to do is I want to kind of get rid of this cosine squared x in the denominator here. And the way I'm going to do that is I'm going to try and use one of my trig identities. But I don't have a trig identity for 2 minus cosine squared x. I only have a trig identity for 1 minus the cosine squared. 1 minus cosine squared is sine squared, of course. So I'm going to go ahead and change the 2 into a 1 plus 1, because 1 plus 1 is 2. So we have 1 plus 1, that's 2. We're going to subtract cosine squared x, that's a squared, dx. And then this whole term, the 1 minus cosine squared, that is actually just sine. So we can just say this is cosine of x over 1 plus sine squared. Right? Because sine squared plus cosine squared is 1. So 1 minus cosine squared is sine squared of x. That is absolutely awesome. And we're going to go ahead and do a quick little u substitution here. If I can, there, it will cooperate with me. All right, let's not forget we have limits on the problem. So we have 0 to pi over 2. Pi over 2. All right, so I'm going to go ahead and say I want, what's this looking like? Well, this is actually a derivative. We could say it's the derivative of sine. So if u is sine, then we can have 1 over u squared. That's an arctangent rule. Sine x, then du equals cosine x dx. So we could say it's the integral of 0 to pi over 2 of du, that's the numerator, of 1 plus u squared. That's arctangent, and we know arctangent is the arctangent of u. Well, u is just sine. U of sine x, not plus c. It's actually a definite integral from 0 to 2 pi. And we can actually work that out right down here. So the arctangent of sine x from 0 to 2 pi. So we can just go ahead and dump in that first one and then dump in the second one. So we have the arctangent of sine of pi over 2. I think I might have said 2 pi. I don't mean 2 pi, I mean pi over 2. Minus the arctangent of the sine of 0. Well, the arctangent of the sine of 0, the sine of 0, of course, is 0. So that makes that 0. And the arctangent of 0, i.e. if we have a triangle like that, and the ratio of the sides is 0, or 0 over 1, we don't have a triangle because one of the side lengths is 0. You can't have a triangle with a side length of 0. So that, we ignore that. That goes away, it's 0. Because the angle for a triangle that has a side length of 0 is going to be 0. In other words, it's just a line. So now we're just left with this. So the arctangent of the sine of pi over 2 with the sine of pi over 2 is 1. So the arctangent of 1. Well, the arctangent of 1 is saying, okay, we have a triangle. And the triangle has angle theta. And this side to this side is 1. The ratio is 1. Or they're the same, right? They're the same length. So if they're the same length, it must be a 45, 45, 90 triangle, or theta must be equal to theta, and theta is equal to pi over 4. And that is our answer. Good work, everyone. Good use of our knowledge, and I think that was a pretty fun problem. Good introduction to kind of remembering how to do definite integrals.